The first thing we need to talk about is displacement. Displacement you can think about as being a change in position. Okay. Position for our purposes is going to be where an object is located in reference to another object. So we're always going to reference something else, like it's moved 5 meters from this particular location. The equation for displacement is very simple. Okay, delta x, which is our displacement, is equal to x final, our final position, minus x naught. A lot of times you'll just see it written like this, that delta x equals our x at some point later in time, minus x naught, our initial position. So anytime you see the little naught here, that's going to be our initial position where we're starting. So it's how far I've gone from where I've started. For example, the teacher here started at an x naught of 1.5 meters from our reference point over here at our origin and walked 3.5 to a position that was 3.5 meters away from the origin. So our delta x was x final minus x initial, so 3.5 minus 1.5, which gives her a displacement of 2 meters. Now displacement, you might notice, is kind of similar to distance, like how far we've gone, but there's a very slight but important distinction here. So let's take, for example, somebody starts at position 1 here, and they walk around in a path like this and end up at position 2 over here. The distance that the person travels is the total length of this path. So distance is total length of the path. So if we were to measure all along this path, how many meters that was, that would be distance. Okay. Displacement, on the other hand, is how far we've gone from where we've started. It's our change in position. So our displacement, our delta x, would only be straight line from here to here. That would be our displacement. How far are we from where we've started is another way to think of it. So that's a key difference between distance and displacement. Vectors are something that are very important to us. Vectors are something that have both a magnitude and a direction. Okay. Displacement is actually the first vector that we work with. Vectors we usually indicate with an arrow, and that gives us the direction part of it. So say we're going this direction. And a magnitude is the value that we associate with that, right? The numeric value. So for example, this arrow might be a displacement, us going from here, this location to here, and that was a displacement of 5 meters. So it's 5 meters in this particular direction. That direction, a lot of times we're going to use an angle for. So maybe there's north and east, and this might be a 20-degree angle. So we could describe this person's displacement vector as being 5 meters going 20 degrees north of east. Right? So it includes 5 meters, the magnitude, and it includes that angle for direction. So vectors must have both a magnitude and a direction. On the other side of things, we can have a scalar. A scalar quantity includes just a magnitude. Distance, for example, would be a scalar. So the scalar quantity for this particular thing would be we've got a distance of 5 meters from beginning to end. Okay? But again, no direction associated. So a scalar just has a magnitude. Vectors have magnitude and direction. Velocity, or average velocity in this case, is going to be equal to our change in position or our displacement per change in time. So another way of writing that would be our displacement, x minus x naught over t minus t naught. A lot of times t naught, our initial time, would be 0 seconds, right? It's whenever we start our clock to time it. So most of the time you'll see this written as x minus x naught, or just displacement delta x over just t, how much time has elapsed. Velocity is a vector, right? Displacement here is a vector. We have to specify a direction. And so the same thing is true for average velocity. One way that we do this with velocity is we use signs positive or negative velocity. And that just indicates a direction. So if we have a positive velocity, let's say we have 0 and then going up in a positive direction here or negative there. A positive velocity would mean that we could be anywhere along here, but we're headed in this positive direction. Right? This would be our positive direction over here, our negative direction. And this would be our 0, our reference point. So we could be anywhere along here. We could have a negative position, but be headed in a positive direction. If we're headed in a positive direction, we have a positive velocity. If we're over here or anywhere along here and we're headed this way, that means that we have a negative velocity. We're heading in a negative direction. So that's where the direction part of that vector comes into play. It's very important that we know the difference between velocity and speed. Okay, so let's take a look at our example here again where we had a person traveling from point 1 to point 2, and they do some path like that. We have our distance, right? Speed would be our distance divided by the time it took to cover that distance. Okay, a pretty straightforward thing that I think we kind of instinctually know. Velocity, on the other hand, would be from point 1 to point 2. There's delta x, and our average velocity would be delta x over t. So you can see we get two different answers from that because of the fact that velocity is a vector and that displacement is just measuring from point 1 to point 2, how far did we go in that period of time. Another kind of interesting example to look at that illustrates this point is if we traveled in a circle like that where we started and ended at that same location. Well, our distance again would be just around the circle divided by time, but our velocity, if we look at our displacement here, our displacement in this case was 0 meters. All right, we started and ended at the same location. So that means our average velocity would also be 0 meters per second. So it's possible to travel in a path and have a speed and have a distance, but have 0 velocity and 0 displacement because of the difference in definition there.